Good afternoon, everyone. Thank you for coming because this is the last slot, and I know that you had already many interesting sessions. Hope that you will learn also some interesting things at this last slot, which is about anomaly detector and multivariate anomaly detection. We will have some scenarios where you can see how you can make quite interesting solutions using digital twins and anomaly detector, especially for complex systems. And this is something which is still in preview, I mean multivariate anomaly detection, so probably for most of you, this will be something new and interesting. But how many of you actually have experience with anomaly detector? One, that's good. And how many of you have experience with digital twins? Okay, I will try to cover both of the topics. My name is Mihail Mateev. I'm from Bulgaria. I work on Azure solutions from the beginning, from 2010, and I'm mostly focused on Internet of Things and related platforms when it is the point what kind of solutions I design and do consulting. So we will talk a little on digital twins, and after that we will go ahead with anomaly detector. So, digital twins is very interesting turning point for many industry solutions because we can apply formally many different analyses to various models. I will try to explain, but first few things about history. Actually, it is not a pretty new concept for IT. It is 20 years old and initially was actually proposed like a solution for PLM systems where it is possible to improve solution having digital replica where you can see how actually parameters are changed. You can make some additional tests. You can change parameters and push back configuration to the original system. So with few words, digital twins offers concept where to physical or digital system you have digital replica. This digital replica collects data from the original system. The level of granularity depends on your purpose. It could be more simple model, it could be very complex model. Depends on, of course, your goals. This model can be analyzed at real time during the life cycle of the original system. You can change it, see what can be improved, and after that to push back updated configuration to the original system. These kind of solutions actually work for complex machines, for aerospace, and this is one of the areas where you have really very good application of such kind of solutions. I will go a little bit faster in the more conceptual part to be possible to see the practical part. So,
I have a question.
Yeah?
Do you know an example of using this digital twin concept against, for example, like financial organizations, like for modeling financial department, for example?
You can model any kind of solution. I mean physical or software solution. So in finance, one of the things where you can apply such kind of solution is related to actually monitoring and improving of systems where you have flows. For example, systems where you have flows can be replicated and you can analyze how it works and to change some things in real time. Yes, it is something interesting. I'm not expert in financial models, but conceptually you can apply to any area. Again, it is something that can be applied for physical systems like machines, sport cars, aircrafts, rockets, whatever, and to different software systems. In general, I will mention this a little bit later. There are some specific differences between digital twins concept and systems which you are using, for example, for simulation. Because here you have one concept that can be used for many different purposes. And this is the most important. Why? We need it, for example, for many solutions like essential part. Because you have different services for analysis on the right side. And you have, some connected devices, machines, or software systems. How to make this connection between original systems and different solutions for analysis in a way to apply formally different types of analysis, to have no very complex custom solution for analysis, to not depend so much on specific model, because digital twins can build a model and you can get some metrics directly from digital twins and to make on an abstract level your analysis. That is the most specific part when you have such kind of concept. And actually, simulation, for example, is something which you are using mostly to simulate behavior of some solutions. Design concepts like, for example, because I have experience in construction, building information model is focused mostly to make a model for design. But here you can have from one side design, from another side simulation, and you can have real-time monitoring and maintenance with one concept, and to simplify analysis for monitoring and maintenance. So this is the most important in digital twins in general, on the conceptual level. And for example, I'm giving here some samples how you can just design something. With digital twins, you can also design many modern solutions, like, for example, Autodesk products like ANSYS for finite element analysis and other solutions already integrate digital twins, and they can build models based on digital twins. To be possible after that, this model to be integrated with different systems for analysis. That's the main idea here. And why we are talking about digital twins and IoT? It is not necessary digital twins to be part of IoT, but when you collect information from real time, it is something which is really with a big value. Actually, here you have glue, the connections part, that makes solutions simpler, more independent, and makes analysis part more simpler and independent for such kind of solutions. Otherwise, we need to have custom solutions, and in custom solutions, you need to add logic which is not necessary. If you have no such kind of formal approach where you have model and you just use some outputs from specific parameters from the model. So we will talk a little more about Azure Digital Twins, and after that we'll switch to Anomaly Detector in predictive analysis. Why we're talking about Azure Digital Twins? It is a long way in IT industry with attempts to have a multi-purpose solution for digital twins modeling, because most of solutions in the past are specific vertical solutions. For example, focus on IoT solutions. Companies like PTC created some specific, more boutique implementations, but no one created software as a service. And actually, Azure Digital Twins is probably the easiest for use on low level for mass usage digital twins software as a service. And you have option to build models. You can, of course, collect information. You have also one very important part, especially when we are talking about security and multi-tenancy. You can integrate this with identity management very good. And of course, to integrate it with different services in Azure. Probably many of you reading or experimenting or working on IoT knows that in IoT there are specific elements related to configuration of devices. It is simplified version of digital twin, very simplified. Device twin in IoT Hub, in Azure IoT Hub. For IoT Core, for AWS, we have device shadows. Device shadows is very similar implementation. So you have more simplified, usually JSON-based models, where you have two configurations, desired configuration and current configuration. That's the reason to make this parallel. When we have IoT solutions, usually gateway service, which establish communication with devices, currently in Microsoft Azure IoT Hub, use for device configurations this simplified version. But it is very, very simplified, just to have parallel. And digital twin is completely different solution for complex models. When we have device twins, you have just part of this service, actually like functionality where you can manage these device configurations. This is the most important. I will not make overview of platform, but just to let you know, many cloud providers are trying to offer such kind of service, but only Azure Digital Twins is complete software as a service. For others, you need to actually create instances of different services and to have custom development to let them work together. In AWS is in this way. Other platforms even have no option, only with offered services to make this solution, even with custom implementation, and you need to have some core functionalities as custom development. And yes, I just added several points like comparison between different IoT solutions, but our focus is digital twins service. Few things. How exactly we work, I will show you a little bit later. We have by default some limitations, just like notice. You can shift limitations usually when we have software as a service. You have some limitations because software vendor needs to prevent this service from unnecessary usage. And if you want to actually shift these limitations, you need to send request to the support and to explain what you are doing. So there is specific language, Azure Digital Twins definition language, digital twin definition language, and it is JSON with several main words, and you can make your models in several ways. You can use one open source Explorer. It is Microsoft open source solutions. You can use professional software like ANSYS or some vertical solutions for Autodesk. You can create these models even with simple text editor. What is the idea? You have, for digital twins, different outputs. It is optimized to be possible to connect it to IoT Hub, and also you can send to API different requests against REST API, because it is 100% RESTful API like interface for digital twins. Model with creation, update of values, which you have for the current state, can be done in this way, and you are able to have actually event distribution after that, triggering events, and send these events to different endpoints. This is the main concept. Digital Twins Explorer is something like this. We will see if we have time, because our point is a little bit different, but I will provide slides and URLs. You can download it from Git and you can experiment if you want. Usually, for most of communication, for most of communication types, you need to have HTTP end requests. First version was more complicated, supporting out of the box more different services, but in this way, this solution is much more universal. So it could be with Azure Functions, it could be with any services where you can send HTTP end requests. Just Microsoft in their documentation usually always are putting Azure Functions. It is not necessary. It is just solution with RESTful interface. And you can have actually out of the box import of data, for example, from logic apps. You know, logic apps are in the same concept like functions, but it is not needed to write code, and the core of logic apps is the same like for Power Automate. You can have any custom service, IoT Hub, and you can, after that, distribute these messages using usually more general option is using event grid, because via event grid you can send it almost everywhere. Out of the box you can configure different messaging services like Event Hub or Service Bus, depends on what will be your messaging concept. So event routing works in this way. You have event dispatching based on the configuration of digital twins, and based on this dispatching you can have some of these endpoints, and after that with event grid you can make almost everything. What is the idea usually when we have self-improved solution? We have a configuration where based on some logic, we can have thresholds, and we can trigger events if we are outside of some boundaries. This can trigger additional logic. This logic can call different analytics services. And after that, based on the results from analysis, can change the model, can change the configuration. And if configuration, which is change of the replica, works better, later it is possible to push back to the original system updated configuration. In the past, years ago, sport car from Formula 1 working this way. After that, it was forbidden because actually the driver is already not the main player in this game. So in this way, digital twins works. We are creating models in similar way using JSON format. I will have no time to go in details. You can create models. You can make also changing of configuration. Several points about IoT. Usually in IoT solutions, you can use such kind of approach not only for clue, but also for several important parts. One is device configuration management. Device configuration management, for those of you who have experience, probably know that it is very complicated part related to monitoring and management of the devices. Another important part is related to actually connection between devices and backend, because usually gateway service, IoT Hub, works together with digital twins to be possible to have, for example, if you have complex rules for devices, you can have equipment. For example, in one business building, you can have equipment. Equipment can be rented from third company. This equipment can be used for different companies also with different relations, and you need to model this. And digital twins, for example, makes this possible. So this is enough probably for digital twins. And we are going to anomaly detection. Anomaly detection is already not new, probably more than 2 years old service offered as part of cognitive services from Azure. What is the relatively new from the last year or year and a little more? This is multivariate anomaly detection, because at the beginning, anomaly detector service supported only univariate detection. So we will cover a little more details, of course, also from univariate to be possible to compare it with multivariate anomaly detection. But it will be actually mostly to understand what is the difference. So when we have univariate anomaly detection, we are analyzing data from one time series, any kind of time series. Usually it is like black box with logic that can use several algorithms, 6 by default, and based on seasonability of the time series and also granularity, it is possible to make different decisions. I will show you. Usually, you can have specific local anomalies and global anomalies, depending on what you want to have. For local anomalies, quite often you have need to make analysis based on the latest points. For global intervals, you need to analyze the whole time series. For multivariate, you have model where you have many time series which you can analyze together. Here, documentation from Microsoft is not fully detailed. I mean that some details how exactly the complex model works are not published in comparison with univariate, where algorithms are described. We will, of course, talk about specifics in the next slides. So, when and why we need to use such kind of things? First, it is something you can use out of the box. Of course, you need to know what this service is doing, but you have no need to create models in a complex way. Second, you can make it decoupled from your model. That means you have digital twins. For some metrics, you receive data series. You send a single data series or group of data series to anomaly detector, and you receive in the response if you have in specific values anomalies, and after that you can have different logic how to fix this. But you can make with several simple configurations this setup. This is the most important in such kind of solution. So we have 6 algorithms for univariate anomaly detection, but you do not control it. Actually, all these algorithms are offered like part of the internal engine, and to be possible to work with anomaly detector actually makes the following. Receive data, make some extraction of what is needed from this data, analyze if there is seasonality. That means if you have repeatable values or almost the same values per some interval, and if you have such kind of repeatable pattern, you have one of the algorithms. If you have not repeatable patterns, you have other algorithms. First, analyzing is on the high level of granularity, not using all values, and after that, several iterations are done. So it works in similar way. I will show you, yes, also this flow. You have algorithm selection, you have detection on the high level, and after that you have several times filtering of this. So, anomaly detector is stateless, especially for univariate. That means it is not possible to keep some state. You are sending for univariate anomaly detector API whole series and receive actually the severity or some other statistical parameters related to how high is the probability to have anomalies here. So we have for both multivariate and univariate batch analysis for the whole series and latest for the last points. And usually, if you want to have real-time monitoring, you are adding some bunch of values for the latest intervals, checking if there are some anomalies. If you want to have more detailed analysis, you need to send large number of values. And here you can see actually specifics based on local anomalies and global anomalies, detecting these anomalies in the best way is when you have, of course, the whole area, the whole series. Otherwise, you are having just analysis of the latest point. I will not go into details related to configuration, but the most important is to have granularity, and you have after that series with values. You can see later in the presentation materials all these details. And you, by default, interval is 1. You can add custom interval. This is for univariate series. Usually, what you can do, I have different test setups. If you need to have analysis for latest points at real time, it is better to have a connection between some service or application which do analysis and IoT Hub in one or another way, using, for example, Azure Functions or Event Hub, depends on the specifics. And this service is calling the anomaly detector, and it is receiving data. If you want to have batch analysis, usually it's reasonable to persist this data somewhere and to read this data from a specific place. I will show at the end several samples related to this. When we talk about multivariate anomaly detector, we have different time series from different sources, from different sensors. And in this concept, you can have two different types of data for both model training and after that for analysis. One concept is related to multiple tables. That means you need to upload in Azure storage in accessible for anomaly detector service container different files where you have timestamp and specific value. The second is if you have one file, one table, usually this is CVS, comma separate values table, yeah, and you can have in one file all these parameters. More flexibility you have with the first model, of course. In the first model, if you have different timestamps, I mean, if you have the same timestamps for some values, dynamically, anomaly detector creates virtual table where for missing time series is not available value. That means you have no value. For others, you have specific values. And this data is trained. Actually, it is trained internally. You are getting this data into anomaly detector, and model is anomaly detector. What is the difference? Is that you have already uploaded this model into anomaly detector, and there is limitation. You cannot have, I think, more than 10 models in anomaly detector. If you have more, you need to have more anomaly detector services or to recreate anomaly detector. You can delete models, actually, because it is in preview. I have some issues sometimes to delete the models. But technically, API allows also to manage this. We will see example where we will have anomaly detection with one table. The same way can be, of course, with many tables. What is specific when you need to have such kind of analysis? You need to follow a process which for now is not flexible configurable. That means you need to upload these files into storage. This storage can be configured to use managed identity and to give data reader rights to anomaly detector service. For now, it works in this way. It is still in preview. That means it can be changed in the future. But currently, if you experiment, it works in this way. If you have many files, these files need to be in one container, and it need to be on container which is on the highest level. I mean, if you consider to create hierarchical namespaces for Azure storage and to put this data on a lower level, it will not work currently, actually. So you need to have a kind of structure in this way. And I already mentioned about granting of the rights for anomaly detector. API supports several functionalities. Training, you need to train the model. Inference, here actually you can have analysis results. For example, you can have latest results or you can have batch analysis. And you have other operators like list models, for example, and delete models API. In general, this is the main API functionalities. And you can see here training, where you can actually train the model, you can get status. You will see usually you need to check the status till model is trained. Inference, where you have actually sync and sync is for the latest values. For the batch analysis, it is a sync. This is normal. And and you have additional options for list and delete. Here is in different representation the same. Training of the model usually has some limitation, 1 million timestamps. I think that this is something which you can change. Actually, I didn't try to change it. I mean, cannot prove that Microsoft is shifting the limitation, but I think it works in the same way. And behind the stage, we will use here API, but behind the stage, you have RESTful interface with JSONs in this way. Going back, you can see, for example, sliding window is the number of points or timestamps considered for anomalies, because it is not the whole interval. Usually, it is sliding window. Align mode is if you have different sources, how to be aligned. I mean, outer is if you have no in all time series the same values, you will have this timestamp in the virtual table. If it is inner, you should have all, and all others timestamp will be removed. What will be the mode for actually filling of missing values? And at the end of the closing, you will have some questions. If organizers ask about data schema, we have two options, one table and multi-table. Multi-table is if you have many sources. One table is if you have one file. And you can have mistakes, some errors in the API if you do not configure this. And yeah, just a few more things. Start time, end time, it is of course the interval which is considered from the whole series, because you can submit more values and there can be considered just some of these values. And I think that's all. And for example, when you have request, you have response, something which you can see when experiment. And in the response, if you see the raw data, you can have actually many numbers here. So, what you can have usually in such kind of solutions, the most important is that you have in multivariate analysis need first to create the model. So model should be created, should be trained, and after that you need to have comparison, check. Model can be continuously updated based on the new data and can be improved. In the one simple application, solution, sorry, what is important? When you have collecting data, there can be different series. You need somehow to manage this data to be uploaded in the right way. So you need to have some pre-processing. And after that, you can use anomaly detection using some service or application. It could be Azure service. It could be also remote application controlled from your workstation to actually send RESTful request to anomaly detector and try to analyze your data. So we have time for demos. And I will try at least to show some parts, because to make everything will be quite difficult, but at least to show some parts. Yeah, let's see. We have now several things. Going to Azure portal. In Azure portal, I already created one Digital Twins instance. When you create Digital Twins instance, actually, the most important is to configure the access control. I will not go back into these details, but when you create new instance, if applications need to collaborate with Digital Twins, these applications need to be authenticated with Active Directory in general. For some automatic authorization, you need to use Manage Identity. There is nothing specific for such kind of services. I will just try to show, but will not finish the process. Azure Digital Twins. So Azure Digital Twins service actually is relatively simple. You have standard details where you will deploy it, what kind of subscription you will use, and almost this is the most important. Let's put it, for example, here, regional, my IDT service, for example. It should be unique for your subscription. Here, you can assign specific accounts that need to have data owner role. Why? Because data should be configured with specific permission. Who can actually access this data? I'm notifying Digital Twins is not database, so you have temporary state of one solution. Now, in the past, we needed to have custom solutions to persist the previous states. Now it is improved. You can do it much simpler, but Digital Twins has only data which is in the original copy of the original systems at the moment. After that, how it will be accessed, some general things, managed identity, if you want to have managed identity, for example, or not, some tags for deployment, and that's all. I will not make this now. The second important point here is how you are making connection. We are making connection using, in this case, IoT Hub. For IoT Hub to fulfill directly digital twins, you need to configure routing. So in this case, again, I will not go into detail because it takes time, but I have routing to event grid, and event grid already works with function. Azure function actually is updating the model. This is the overall concept, how we are sending data to digital twins. I have one simpler solution like device simulator, and this device simulator actually is sending data to the digital twins. Here, of course, I can configure, think, not only color. Wow. I wanted to make the font a little bigger, but okay. So you see, and we can calling digital twins to get this data. But now I will go into the next stage. Okay, we have this data. For example, scenario which we have here for univariate anomaly detector. I'm running, for example, one sample application, but usually in such kind of solution, this will be internally. This is mostly for demonstration purpose. You have persisted somewhere in file or in memory this time series, and you're sending request against digital twins, against anomaly detector. Sorry, anomaly detector for univariate again is absolutely stateless. Every time you are sending data, anomaly detector analyzing data, and response. Do you have some probability to have anomalies or not? Pretty simple. And based on this, you can analyze univariate series. Now, let's see how it works with multivariate series. I have another demo. Whoop. I even updated it a little bit. Where I have already created anomaly detector service. Let's show it. All resources. Let's make it to by type. And I have here anomaly detector. Give me a second. Service 02. This one. Okay. Any anomaly detector service can be created like others cognitive services. In anomaly detector, except key for authentication and endpoint, we have no need of other things. Access control can be done also from here, but I prefer to use storage. In the storage, I will go to our anomaly detection storage, which is this. And for the storage already, you need to have actually for identity management and control. Under access control, we need to have here check what we have like. Yes, here is our anomaly detection service. I gave more roles now, but this one is enough. You can have only storage blob data reader and it is enough. So what we have in this storage, so we have this container, and in this container we have actually this CSV file. This CSV file, I can even download it and open it. Let's see. Interesting. I will start Excel. Probably this will be, yeah. Okay, so we have something like this in general. Additionally, for simulation of analysis from the last point, I have in, well, because I'm lazy, I have in my test project directly in the place where is my execution file. Just to open it. Let's go and open in file Explorer. Okay, I'm opening it file Explorer. So you can have, of course, path, but I just added here one file which has actually some data for detection of the latest values, anomalies in the latest value. So let's try to take a look at the code which we have in general. So I'm creating anomaly detector client. It is the same if we have univariate or multivariate analysis. The client is the same. After that, we need to have some interval which we will use later. From where to where. We are training the model. For the model, we need to use data source. Data source is already uploaded in Azure CSV file with values, different series. And this is the interval, because start time and time, because we can train again only with part of the values. It is not necessary to have all values. So after that, because it is asynchronous, we need to have detection of the whole data. And here we have different start time and end time. They can be different, but model ID already is needed. This model ID we receive when we start to train the model. Training the model as response receive model ID, and we are checking continuously if the model is ready. For latest detections, we can make actually loading of data from specific file, or to create this in the memory. I will show it a little yellow. Okay, so for batch detect, I'm getting the response and just I'm getting several parameters because each result can have different values. It is actually binary structure. You can parse it in different way. I'm just showing several values. About last values, I'm reading JSON file, which you show from the folder. It could be from anywhere. Actually, you need to create a collection. And in this case, I can have many options. Just I'm reading file, creating JSON. From JSON, I'm creating structure. And I'm receiving, after that, some value for the first one. I'm just checking the first one to be simpler. Now, I will try to show how it works. I have already several models which I did for experiments, so that's the reason to see here more available models. It is part of the API to can check the models. This is the model ID. When we start training, we are receiving this model ID, and we are trying, I think I put it each 5 or 10 seconds, again and again, to see what when exactly the status is ready, because status can be running, ready, or failed. And if it is ready or failed, of course, we will go to the next stage. So after model training, we have detection of the whole model. I'm getting just the first one from the result. Here is detect last result, it is one, and here is the result from the previous for the whole session. Actually, it can be more beautiful. Here, the first result is that actually we have no anomalies. That's the false. When we are checking the latest points, you can have also number of points which need to be which can be considered, and result can be casted. I'm casting it to number. That's the reason here to have result like 0. But you understand the main concept. In this way, we can actually have the whole solution. You have a collection of data. You need to create data sources from your sensors. These data sources, if we have a batch analysis, need to be uploaded. If we have for the final points, it can be streamed at real time, and you can call the multivariate anomaly detector. But multivariate anomaly detector can have already the model, so multivariate anomaly detector actually can persist models, including training models. It is not necessary to use it like completely stateless service. So this is the most important which I wanted to explain in this presentation. The content is too big, so I just had option to show several details. Thank you very much for attendance, and if you have any questions, I'm available to answer your questions, to discuss, and to help you in any possible way to start use anomaly detector and digital twins. Thank you very much.